Okay, hi everyone. This is the third part of the course Statistics for Everyone towards Data Science with R. First, before going to preview of the basics of R coding, I would like to show you how to download and install the R as well as the Rstudio. If you copy and paste this URL in some internet browser, acted HTTP Rstudio.com, and we get this download result IDE and scroll down to got this free version. There are two free versions. Usually the first one is okay. Go to download the first one. We have here download for Windows, and after you downloading, here we have downloading. So this is the RStudio 1.3 1093exe. If double click on, and you can go step by step, just selecting the default versions, and you will be okay. Because I already downloaded, I'm not going to do this. Also, I have a couple of versions I have to remove. Then we go to download the R itself from this URL. cranr-project.org. So you will see we have download R for Linux, Mac, and Windows. Just double click on the window, and then here we have install R for the first time, and here we have download R 4.0.3 for Windows. And we have this R40, R40. We have actually 12 them because I downloaded before. So this is R4.0.3 WinExe, and double click, and easily you can install. And I'm not going to do that because I already did. So it is very straightforward. Now, after doing this, you can open the RStudio. RStudio has a four panel or four windows. The top left panel is called editor window. We can write the codes. The left bottom is console. We can see the codes when we execute it on the Rstudio in the console, as well as also we can do the coding in this console as well as in the editor window. The right panels is the top one is global environment. We can see our codes and the results. Top panel usually is used for plots and downloading packages and some helps. And also when you have a plot or graph, you can save it as a PDF file or GP or other files as you like. So we start from very basic calculations in math. Math we have sum of two numbers, 14 plus 9. We have here 14 plus 9. I am on the editor window, so we go to the run button and we got 14 plus 9, which is 23. 15 minus 12 is 3 on the console. 7 times 8, 56. 100 divided by 3, 33.33. 5 plus 3 times 64. Okay, we got the 3893. We can use our parentheses or brackets for grouping as in done in math text. Bracket 12 plus 13 times 15 to the power of 4. We use double percentage for modulus, meaning that we get when we have A modulus B, we get just the remainder of the division, not the other number division itself. So 100 modulus 30, we should have 10. Okay, we have this log function, and this log function by default is the log base Neperian number E, and 2.7182 is the Neperian number, so the log of this should be 1. And we have the inverse function of log, exponential function, and exponential means e to the power of 1. This should give us the Eulerian Neper number. Exponential to the power of 10 is a little big number. We have also a log in base 10, log base 10, 100 should be 2, log 2, log base 2, 64, 6, means that to the power of 6 is 64, to the power of 4, to the power of 6. The power is double star. You have so 64. SQRT, square root of an argument is square root of 64, which is 8. Round function runs to removing the decimals. We got the integer, rounds argument to the nearest whole number or integer number, round to 1 decimal point, so round just one decimal, round digits minus one, even uh, uh, more than one decimal point, so we round even the last digit of 233, which we got 230. Rounds to 0.4 rounds down to the even digit 2. So if the integer part is even, we got the even, and rounds up to the even digit 4. If this is odd, also this gives us the odd number, which is 4. Floor runs down, which gives us 2. Ceiling goes up, which is 3. Truncate to the whole number, 2. Truncate to the whole number is close to 2 minus, rounds to the direction of 0, minus 2, 6 is uh, less than minus 2, so minus 2 is close to 0, so we have to get minus 2, which is true. Absolute value of minus 10, we have 10. The famous pi number, 3.142, cosine of 0, 1, sine of pi half is 1, tan of pi fourth is also 1. There are a couple of useful functions. They call the mode, the class, and the type of function, which we can find out what type of number or what type of variable we have. By the way, also, in order to write a double or more code in one line, we can do that, but we have to separate with semicolon. So type of 5, semicolon, mod 5, semicolon, class 5. We can do all three together. We got, so type of 5 double, mod numeric, and class numeric. The same for a negative decimal number. We got the same result. The same for minus infinity. We have the same result. Take x as 17.8, and we can print by using the print function. We also get the same result as also using the x itself. Create a complex number, 1 plus 2i. I is the square root of minus 1. Z, which is 1 plus 2i. Type of Z, mode of Z, and class of Z, all complex numbers, integers. Y equal to as integer means even the number is not integer, but we want to get the integer part. As integer, y, which is 3. Class of y, integer. Is integer y? We asking a question, is integer y? True, yes, it is integer. As integer 3.14, the same as integer 3.14, we got 3, the integer part. As character, 3.14 is not character, is a number, but when we ask, give us as character, so we got the double quote around the 3.14, which is not number, just a character. Class of x, character. As integer in this case, 0.27 is a character, but we want to be integers. So we got the number and the integer part, 5. As integer Joe is a character. There is no number here, so we have as falan warning message. Nans produced by coercion. As integer true, yes. Usually true is equal to 1, false is equal to 0 as a numeric. As integer false, which is 0. Square root of minus 1. If we want to get the square root of minus 1 without mentioning the square root of minus 1, without mentioning the I part, we got warning message. In square minus 1, nans produce. So if we want to produce a complex number from minus square root of minus 1, we should write square sqrt of minus 1 plus 0i. So in this case, we got 0 plus 1i. An alternative is to coerce minus 1 into a complex value. SQRT as complex minus 1. This is also works. Logical expressions. Is x larger than y? Print the logical value. X equal to 1, y equal to 2, z as a logical expression. If x greater than 1, z false. X is not greater than 1. Class of z, logical. U is true, V is false. U and V. This is the U and V mathematical statement. U and V. When we have a mathematics statement, one is true, the other is false. U and V is false. U union V or V. In mathematical, we say that U or V is true when one of this is true. So we should get true. The negation of Y. If U is true, we got false. If is false, we got true. U. U is true, so we got false. Two characters can be concatenated with the paste function. First name Joe, last name Smith. Paste first name, last name. Joe Smith. Vectors. We usually use this C letter to produce vectors. C bracket, any numbers, and then we got a vector. This is the simplest type of producing a vector. Mod V is numeric. Type of V is double. Class of V is numeric. The standard assignment operator in R is this symbol, which is less than, is left diamond bracket is a left diamond bracket followed by a minus sign. It means is assigned to. The function C stands for concatenate. Usually this assignment is preferred for um, getting uh, different values of numbers or vectors or whatever we want to use, uh, with comparing to the equality, which sometimes doesn't work. So it's good practice to use this assignment operator. So we have here also vector C, we call it U, vector C 7.8, 4, minus 6, 7.6, V is vector 367, and we can also use the same C as concatenation to concatenate U and V. So we have U and V, and what is the U? We have all the numbers in U and V. Z equal to minus, we use this um, double point minus 5 to 8 from minus to 8. Minus 5, minus 4, minus 3, minus 2, minus 1, 0 until 8. Note that the double point operator is used to create integer sequences. To access to an element of vector, we use brackets like v1, which means that first element, where length is the number of the elements in the vector with. The number inside the bracket is called the index of the corresponding element. We use the length. So what is the length of V? We know the V have 1, 2, 3. Length of V. What happened here? Length V. Length V is 3. V from 1 to length V. 360. 360. To get the first 6 element we use, to get the first and 6 element, we see first element, 6 element. To remove some elements, we use negative indices. Remove the fourth element from V. But we don't have fourth element in V. Let me see. We have only 3 elements, so there is no fourth element. So there is no fourth element because we got the same. Remove elements from 2 to 4, we got just 3. Remove elements 1, 3, 5, we got just 6. Vectors with logical and character elements. Vector we have here, vector C, true, false, true, false, true, true, false, false. What is L? What is the type of L? Mod L and class L. So we have the vector and type, mod, and class all logicals. Vector with all character numbers, characters. Give the vector and type and mode and class. Vector AA, BB, CC, DD, EE, and all the three functions gives us the character. We may insert some other numbers between U and V2. So we can write W concatenate U, and after U we insert 88, minus 43, 100, and V. We have all the numbers. If we want to make a vector from consecutive numbers, we can use consecutive numbers C minus 4 to 6, which we already did. U is this number. We can use also without C. We can start from empty vector. V is vector, empty vector, and add the elements. V1 minus 6, V2 7, V3 4. What is V? Minus 6, 7, and 4. Instead of indices, one can use names of the elements. Start from empty vector, then instead of the indices, we call the first vector A, the second vector B, third vector C. The first vector 5, second vector, the first number 5, the second number minus 24, the third number 70. And U is given this A equal to 5, B minus 24, and C equal. We get the names in this case, names of U, A, B, C. To get a subset of vector, we use V0 equal to 1, V1, and V0 numeric 0. So we see that the 0 indices doesn't work. Here we have V from 3 to 5. We have, as we have just three numbers, we start with 4. V is 4 the third element, and then after 4 is, if there is no numbers, we got nan, na, and na, which is nan. Again, we have the w as character vector, and we can find the lengths 1, 2, 3, 4, 5, and both gives us the same answer. The vector type is really the heart of R. The elements of a vector must all have the same mode or data type. One can have a vector consisting of three characters, mode or characters, or three integer elements or mode integers, but not a vector with one integer element and two character elements. So the vectors only can have just one mode, which can be number, decimal, or whole number, or which can be character. Here we have the examples. U as a number, you got the numbers. As you see, we have one of these numbers is in decimal continuous numbers, or the whole number, the others given the 7.0 and 8.0. We have the character vector of the character. If we concatenate u and v, we got all numbers which are in the mode of a character, as you see. Two different way of subsetting of a vector. Suppose x equal to c, 6, from 1 to 3, 1, 2, 3, NA, and 12. So x is equal to 6, 1, 2, 3, NA, and 12. X such that x greater than 5. All elements which are greater than 5. 6, NA, 12. Subset x greater than 5. 6, 12. In this case, we didn't get the NA number. Finally, we got this vector arithmetic, a equal to c, 1, 3, 5, 7, b equal to c, 1, 2, 4, 5, 4, 8, and 5 times a, 5 times a, 5, 15, 25, 35, a plus b, a minus b, a times b, finally a divided by b, which is element-wise. Principle of recycling. When applying an arithmetic operation to two vectors that requires them to be the same length, are automatically precycles or repeats the shorter one until it is long enough to match the longer one. Here is an example. So we have u 1, 2, 3. We have v 1, 2, 3, 4, 5, 6, 7, 8, 9. U plus v, u plus v. 110, 220, 22, 3, 30, 33, and then 4, we have 14. Again, 4 plus 10, 5 plus 20, 6 plus 30, and again 7 plus 10, 17, 8, 28, and 39. The same as u minus v, the same as times, and the same as division. Other functions to generate vectors. We have the seq sequential from 1 to 30 by 4. By 4 means 1 plus 4 plus 4 plus 4 plus 4 until we got less than 30 or equal to 30. Why? Why 1, 5, 9, 13, 17, 21, 29, 20, 25, 29. And then the 5 by 29 is more than 30, which we cannot get it. Sec 0, 100 by 10. We can use also this one. From 0, 0 plus 10, plus 10, plus 10. So we got 0, 10, 20, 30, and so on. 10, 20, 30, 40, and until 100. Rep, rep, repetition, it repeats 120 times. Repeat x1 20 times. 120 times. Repeats from 2 to 5. 2, 3, 4, 5, each 3 times. 2, 3, 5, 2, 3, 5, 2, 3, 5, 2, 3, 5, 2, 3, 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5. Run if uniform random numbers, uniform random numbers, the number of the with just 8 numbers with minimum 0 and maximum 100. One more function which we use more often to do random sampling is sample. Sample one from 1 to 10, 10 numbers. From 1 to 10 sample. It is random sampling, but we got 10 numbers between 1 and 10. So between number and 10, 3, 9, 8, 10, 4, 7, 1, 6, 2, 5. If we do again, we got different numbers. So 1, 2, 3, 6. Do again. Every time we got different numbers. If we want more from same number, we use replace equal to true. Otherwise, it throws an error. So if we want this as one sample from 1 to 20, from 1 to 10, 20 times, which is not possible. If we use this replace true, means that we can sample among 1 to 10 and we want to get 20, but replacing is permitted, is allowed. Sum of rolling of pair of dice 1 times. Sample 1 to 6, just 1, plus sample 1 to 6, just once. And then sum them up. 4, 5, 11, probably 8, 4. And the same we have size 1. 1 from sample from 1 to 6. The size we want to get 5, and then the same we want to get 5, and then sum them up. 11, we want this one both 6. Okay, that's it for this lecture. I hope you enjoyed this part, and next time I'm going to go to um, do introduce matrices and arithmetic of matrices, and after the matrices we have data frames, data frames, and after data frames we have lists, which is the general types of um, data type which accept time, any type of data inside the list, and go to the other sections. Thank you very much for your attention, and see you next time. Bye now.